Hello everybody, welcome to the channel. Welcome to IT Skills. I'm your host today, Aiden, and in this video, we're gonna discuss a very important course, and that is the
MS-900T01, a learning path. Describe cloud concepts. Let me know when you're ready for me to start presenting it.
Go ahead.
All right, let's begin. This presentation is about the MS-900T01A learning path, and it focuses on describing cloud concepts. We'll delve into the fundamental ideas and principles behind cloud technology. Do you want me to move to the next slide?
Yes.
The agenda for this learning path includes describing cloud computing, the benefits of using cloud services, and cloud service types. Now, let's move on to Module 1, which focuses on describing cloud computing. Do you have any questions so far?
Keep going.
All right, in Module 1, after completing this module, you'll be able to define cloud computing, describe the shared responsibility model, define cloud models including public, private, and hybrid, identify appropriate use cases for each cloud model, describe the consumption-based model, and compare cloud pricing models. Do you have any questions about the learning objectives of Module 1?
I do not at the moment.
Let's move on then. The next slide explains what cloud computing is. It says cloud computing is the delivery of computing services over the internet, enabling innovation, flexible resources, and economies of scale. The slide also includes a visual showing three main components of cloud computing: compute, networking, and storage. Would you like me to elaborate on any of these concepts?
Yes, I'm on a circle for you and I want you to elaborate it.
I understand. You'd like me to elaborate on the compute aspect of cloud computing, and I can do that.
So elaborate on what I just circled.
Let's talk more about the compute aspect of cloud computing. When we say compute, we're referring to the actual processing power that's needed to run applications and services. In the cloud, you can access a variety of computing resources, like virtual machines, that you can use to execute your tasks. Does this help clarify the compute aspect?
Yes, about networking.
All right, let's talk about networking in the context of cloud computing. Networking is all about how different components and devices communicate with each other. In the cloud, this involves connecting virtual machines, storage, and other services, often over the internet. This allows for seamless data transfer and connectivity between various resources. Is there anything specific about networking you would like me to elaborate on?
Yeah, elaborate a little bit more about networking.
Let's dive a bit deeper into networking in cloud computing. Cloud networks are often more complex than typical home or office networks. They use various technologies like virtual private clouds, VPCs, to create isolated network environments, and technologies like load balancers to distribute traffic across multiple servers. They ensure reliable and secure communication between different parts of your application. Does that give you a better picture?
Yes, that gives me a great picture.
Great. Now that we have a better understanding of compute and networking, do you want me to continue with storage or move on to the next slide?
Storage.
Let's talk about storage in the context of cloud computing. Cloud storage refers to the various ways of saving and accessing data in the cloud. This includes object storage, like storing files or images, block storage used by virtual machines, and file storage for shared access. This cloud storage allows for data to be accessed from anywhere with an internet connection. Would you like me to elaborate on any specific types of storage?
No, we'll move on to the next.
Let's proceed to the next slide then.
So over here we have private cloud. Can you explain everything about the slide?
Certainly. This slide is about private clouds. It explains that organizations create a cloud environment in their own data centers when using a private cloud. These organizations are responsible for operating the services they provide in this environment. A key characteristic is that private clouds do not provide access to users outside of the organization. So it's self-contained within a single organization. Is there anything else you would like to know about private clouds?
No, we're good. Continue on to the next one.
Let's move on to the next slide.
So about the public cloud.
This slide is about public clouds. Public clouds are owned by cloud service or hosting providers, and they provide resources and services to multiple organizations and users. They are typically accessed via a secure network connection, often through the internet. What are your thoughts on this slide?
Interesting. So give me some example of public cloud.
Some common examples of public clouds include Microsoft Azure, Amazon Web Services, AWS, and Google Cloud Platform, GCP. These are all major providers that offer a wide range of services to their customers. Would you like to discuss the services they offer?
Oh, no, we're good. So you talked about Azure, right? GCP and AWS. This is an example of private cloud or
Yeah,
public cloud.
right, you got it. I mentioned Azure, GCP, and AWS as examples of public cloud providers. We previously discussed private clouds as well. Do you want to compare them or move on to the next type of cloud?
Let's compare them.
Let's compare public and private clouds. Public clouds are multi-tenant, meaning many users share the infrastructure, while private clouds are single-tenant, meaning only one organization uses the resources. Public clouds are generally more cost-effective and scalable, but might have less control over security and compliance compared to private clouds. Private clouds offer higher levels of control and customization, but they can be more expensive to maintain. Would you like a comparison of any specific aspect?
Explain why they could be expensive to maintain.
Private clouds can be expensive to maintain because the organization is responsible for all the infrastructure, including the hardware, software, and personnel needed to operate the data center. This requires upfront investment and ongoing operational costs, unlike public cloud, where those costs are usually shared with other users.
Wonderful. Let's move on to the next slide.
Let's go to the next slide.
Over here we have hybrid cloud. Explain the benefits and everything about it.
This slide is about hybrid clouds. A hybrid cloud combines public and private clouds, which allows applications to run in the most appropriate location. This offers flexibility and control, using a combination of public cloud for scalability and private for secure and sensitive data. Do you have any questions about hybrid clouds, or shall we move on?
Let's get an example of the hybrid cloud models now.
An example of a hybrid cloud model could be an organization that uses a private cloud for sensitive data storage, but utilizes a public cloud for things like their website or less sensitive applications. This allows them to take advantage of scalability of public cloud while maintaining the security of a private cloud. Is there anything else I can elaborate about hybrid cloud models?
I said, based on what you said, we wanted to go ahead and use private cloud for PII data. That's personal, confidential. And then everything else that's not confidential, we'll use it for public cloud. Is that correct?
So you're saying that based on what you've previously stated, you'd use a private cloud for PII data that's personal and confidential, and then everything that is not confidential, you'd put in the public cloud. Is that correct?
That's correct. Is that right?
Yes, that is a good use case for a hybrid cloud. It leverages the strengths of each model, with public for less sensitive data and private for PII data, which is both personal and confidential. Do you have any more questions, or would you like to move on to the next slide?
You know what? That's so far so good. Let's move on to the next slide.
Let's proceed to the next slide then.
This is the slide about comparing the cloud, comparison of the cloud models we discussed. So go ahead and just explain each part of the comparison. So far, we're going to continue presenting it. We left off over here. So go ahead, explain the comparison model between private, public cloud, and hybrid cloud.
Sure, I can describe the cloud model comparison presented on the screen. There are three types of cloud models described: public cloud, private cloud, and hybrid cloud. Public cloud has no capital expenditures, applications can be quickly provisioned, and organizations only pay for what they use. Private cloud requires hardware to be purchased for startup and maintenance, provides organizations complete control over resources and security, and the organizations are responsible for hardware maintenance and updates. Lastly, hybrid cloud provides the most flexibility. Organizations determine where to run their applications, and organizations control security, compliance, or legal requirements. Does that help?
That's very helpful. Let's continue.
The slide is titled, Compare CapEx and OpEx. It contrasts capital expenditure, CapEx, with operational expenditure, OpEx. CapEx is described as the upfront spending of money on physical infrastructure, and that costs from CapEx have a value that reduces over time. OpEx is described as spending on products and services as needed on a pay-as-you-go basis, and that the user gets billed immediately. There is also an image below these bullet points that is an arrow going from a stack of bills to 3 individual stacks of bills, implying the same amount of money being spent over time. Do you need more details on the slide?
Yeah, explain CapEx first, more.
Let's dive deeper into expenditure, or CapEx, is when you spend a large amount of money upfront to acquire physical infrastructure. This could include things like servers, networking equipment, or office buildings. While it's a large initial investment, these assets have a value that reduces over time through depreciation. In other words, the value of the asset is reduced each year, which can lower your company's tax burden. Is that a helpful explanation of CapEx?
It is instance where CapEx doesn't get lower over time due to inflation or technological changes.
Right. There are instances where CapEx doesn't necessarily decrease over time. Due to factors like inflation or technological advancements, some assets may actually retain or even increase in value. For example, land can become more valuable over time due to inflation, and an upgrade to a piece of equipment can lead to it being sold at a higher price than the original purchase price due to technological changes, even if it has been used. Would you like to delve deeper into other examples?
No, that's good.
Let's talk about OpEx then. Operational expenditure, or OpEx, refers to the ongoing costs of running a business. This includes day-to-day expenses such as rent, utilities, and employee salaries, or even cloud services, where you pay for the resources as you use them. These costs are typically billed immediately and don't involve large upfront investments. Is there anything specific about OpEx you would like to discuss?
Go deeper into this.
Let's go deeper into OpEx. It's characterized by its flexibility and scalability. Businesses can easily adjust their spending based on current needs, and it's also a good choice when you're trying to keep your initial investments low. With OpEx, you also don't need to worry about maintaining hardware or infrastructure, as that is often the responsibility of the vendor you're working with. Would you like more clarification or examples regarding OpEx?
Give me some organization that would use OpEx.
A good example of an organization that would use OpEx is a startup company. They typically have limited upfront capital, so they would choose a cloud-based solution for their IT needs, allowing them to pay as they go rather than investing in expensive physical infrastructure. This would also allow them to adjust spending based on fluctuating needs as they scale. Would you like another example?
No, we're good.
Let's move on to the next slide. It's titled Consumption-Based Model and explains that cloud service providers operate on this model, where end users only pay for the resources that they use. It mentions a better cost prediction, prices for individual resources and services, and that billing is based on actual usage. Do you want me to elaborate on anything in the slide?
Yeah, elaborate about the cost prediction and then the prices and also the billing of actual usage.
Let's start with better cost prediction. In a consumption-based model, because you only pay for what you use, it becomes easier to predict and manage costs. You're not paying for unused capacity or resources, so you can accurately budget for your cloud consumption. Next, the slide mentions prices for individual resources and services are provided. This means that you can view clear and separate pricing for each individual resource and service you use, so you know exactly where your money is going. Lastly, billing is based on actual usage, means that your bill reflects your real-time consumption of the resources. Do you want me to expand further on any of these points?
No, we're good. Let's move on next.
Next slide is titled Module 2. Describe the benefits of using cloud services.
Let's move on.
Slide now says Module 2, Introduction. It indicates that after completing this module, you will be able to 1. Describe the benefits of high availability and scalability in the cloud. 2. Describe the benefits of reliability and predictability in the cloud. 3. Describe the benefits of security and governance in the cloud. And 4. Describe the benefits of manageability in the cloud. Should we delve into each of these benefits?
Wait, let's continue to the next slide. We will dive into the next slide. So go ahead now, explain the benefits.
Slide is titled Cloud Benefits, and it highlights 3 benefits: high availability, scalability, and elasticity. High availability is shown in a peach-colored box, scalability in a purple-colored box, and elasticity is another peach-colored box. Do you want me to elaborate on any of these?
Explain more about high availability.
High availability in the context of cloud computing means that your applications and data are always accessible or available, even if there are hardware or software issues. Cloud providers achieve this by having redundant systems in place. For example, if one server fails, another server can automatically take over so your application stays online. Is that clear enough, or would you like more detail?
Connect that to Azure regions. How is that plays in together?
When we talk about high availability in the context of Azure regions, it means that Microsoft has data centers distributed around the world. These data centers are grouped into regions. If you deploy your application across multiple Azure regions and a region experiences an outage, your application will stay online because the application in other regions will continue running. Is this a helpful explanation for you?
Let's move into
Okay,
scalability.
scalability refers to the ability of a cloud service to handle increasing or decreasing demands. If your website suddenly gets a lot of visitors, the cloud can automatically add more resources to handle the load. And then when things quiet down, those resources can be released to keep costs down. Do you want me to go into more depth about this?
Explain scale out, scale in model in scalability.
Scaling out means adding more servers or resources to handle an increased workload. Imagine having more tables in a restaurant to accommodate more customers. Scaling in means reducing the number of resources when the workload decreases. This would be like removing tables from the restaurant when there are fewer customers. So it's scaling out for more and in for less. Do you want me to
So
clarify?
that's a good one, but can you explain scaling out in the sense of sports and also scaling in the sense of sports as well?
Let's think of scaling out in the context of a sports team. If a team is performing very well and gaining a lot of popularity, they might scale out by adding more staff, like coaches and trainers, and improving their facilities to accommodate the increased demand. When a team loses their popularity, they might scale in, reducing staff and resources to match the lower demand from fans. I see your slide now. It's about cloud benefits, and you've highlighted high availability, elasticity, and scalability. You mentioned you're currently stuck on scalability, and want me to explain more about what scalability means in the sense of a business and what its use is in a new business model. Is that right?
That's correct.
Great. Let's dive into scalability then. In a business context, scalability refers to a company's ability to handle increased demands or growth without negatively impacting its performance or resources. It's about being able to easily adapt as your business expands, whether it's in terms of customer base, transactions, or data volume. Does this definition make sense to you?
Yes, so when you're launching a new website in the sense of scalability, the website is getting a lot of traffic, you scale out. And when you're losing a lot of traffic, you're not getting a lot of sales going on, then you scale in. Is that about what you're thinking?
Yes, that makes sense. So if you're launching a new website and it gets a lot of traffic, you scale out. And when traffic decreases and you're not getting many sales, you scale in. It's about dynamically adjusting resources to meet the current demand. Is that a good summary?
That is a good summary. Let's move to elasticity.
All right, sounds good. Let's talk about elasticity. Elasticity, in the context of cloud computing, refers to the ability to automatically adjust the amount of resources, like computing power, memory, or storage, that are allocated to an application or service based on the current demand. Is that the direction you wanted me to take?
Yeah, go ahead.
So think of elasticity like a rubber band. When demand increases, the system automatically expands to handle it and then shrinks back down when the demand decreases, all without needing manual intervention. This allows businesses to optimize costs by paying only for the resources they actually need. Does that make sense?
Yes. About in the sense of a new business, how can they use elasticity as a way to benefit their business and save money?
So in a new business model, elasticity can be a game changer. For instance, if a new online store anticipates a surge in traffic during a holiday sale, they can use elasticity to automatically increase their server capacity to ensure the website doesn't crash. Then, once the sale is over, the system will automatically scale back down, reducing costs. It's about being adaptable and efficient with your resources. Does that illustrate its usefulness?
Now, there's a confusion for some audience maybe about scalability and elasticity. Can you explain the difference?
Right, it's easy to get those two confused. So, while both scalability and elasticity relate to resource management, scalability is about increasing or decreasing resources to handle the overall size or capacity of your system, whereas elasticity is about automatically adapting to changing demands in real time. So you use scalability when you know your business will be growing, and use elasticity when you need a system that automatically adapts to fluctuations in demand. Does that help clarify it?
That is perfect. Let's move on to the next slide. How about
Great.
reliability?
Let's move on to reliability. In the context of cloud computing, reliability refers to the system's ability to consistently perform its required functions without failure, even when faced with unexpected circumstances or high demand. How does that initial definition sound to you?
That's pretty good. Explain that reliability in the sense of SLA and 99.99% uptime.
So SLA stands for Service Level Agreement. It's a commitment from the cloud provider to maintain a certain level of service availability, often measured as a percentage. In your case, it looks like you've written SLA is equal to 99.99%. This means that the provider guarantees that the service will be operational 99.99% of the time. Is there anything more you'd like to know about this?
No. So that's what makes the cloud reliable, right? Because of the fact it's up all the time, you don't have to worry about going down because of the compute or virtual machine or any application, correct?
Yes, exactly. The SLA with a high percentage like 99% means you can rely on the cloud service to be available when you need it, minimizing downtime for your business, which is a crucial factor for reliability. Is there anything else I can help you with regarding this slide?
How about predictability?
Let's discuss predictability. In the context of cloud computing, predictability refers to the ability to reasonably foresee the performance, cost, and behavior of the system. It's about ensuring consistency and stability in how the cloud environment operates. Does that initial definition make sense to you?
That's perfect. You're predicting the cost, you know what you're going to pay every month, therefore, there's no surprises. That's what we love.
Precisely, with predictability, you can plan your budget knowing what to expect month after month, avoiding unwelcome surprises. So you're predicting the cost, you know what you're going to pay each month, and there are no surprises, correct?
That is what we like. So that's what a lot of companies like. So, in any case, let's see if we can move on now.
Understood, predictability is definitely a desirable quality, and a lot of companies find it beneficial. So, is it time to move on to the next slide now?
No, we need to talk about security. It's very important.
Security is definitely a crucial aspect. In the context of cloud computing, security refers to the measures and practices put in place to protect data, applications, and infrastructure from unauthorized access, misuse, or damage. That is the main concept of security, right?
Right. All right, guys, you can see over here, we're presenting thanks to the help of AI. And I hope you're liking this type of video because if you do, I can do a bunch of this type of courses. We can learn together and you guys can actually be able to take notes and see that what AIs have to say about this one. So if you like this type of content, courses, you name it, please subscribe and consider becoming a member. It will help us so much. Let's move on.
I see that you're now showing a screen with a presentation about cloud benefits, specifically about security. It looks like you've already discussed high availability, elasticity, scalability, reliability, and predictability. And now you would like to discuss security in the context of the cloud, is that right?
That's correct.
All right, please continue with your presentation when you're ready.
No, I want you to explain it. You are presenting for me. I am literally just correcting, adding notes as needed. I'm helping you.
I will elaborate on the security differences between cloud and on-premise solutions.
First, before you elaborate, talk about the security in the sense of cloud benefits.
So before comparing the security of cloud and on-premise solutions, you'd like me to talk about the security benefits of the cloud first. Is that correct?
That's correct. Go ahead, explain security in the sense of cloud benefits.
Let's talk about the security benefits of the cloud. One major benefit is that cloud providers invest heavily in security infrastructure and expertise. They have dedicated security teams and use advanced technologies to protect their systems. This often surpasses what a typical organization can achieve on its own.
What are one of the most, you name some of the security compliance with Azure has, some example?
You want to know some of the security compliance certifications that Azure has as an example, is that correct?
That's correct.
Azure has a wide range of compliance certifications, including SOC 2, ISO 27001, HIPAA, and GDPR. These certifications demonstrate that Azure meets specific security and privacy standards. Would you like me to explain any of these further?
No, let's move on. Governance. Explain governance, please.
Let's talk about governance in the cloud. Cloud governance refers to the policies, processes, and tools used to manage and control cloud resources. It ensures that cloud usage aligns with business goals, security requirements, and regulatory compliance.
Give me more information about that, how governance can help organizations stay protected.
You want to know how governance can help organizations stay protected? Effective cloud governance helps ensure that security policies are consistently applied across all cloud resources, reducing the risk of misconfigurations or vulnerabilities. It also enables organizations to monitor and audit access to cloud resources, preventing unauthorized access and data breaches.
Good. That's very good. Let's continue. Let's move on to manageability.
Let's discuss manageability in the context of cloud benefits. Cloud manageability refers to how easily you can control, monitor, and maintain your cloud resources. Cloud platforms typically provide tools and services that make it easier to deploy, configure, and manage infrastructure and applications.
That's cool. Well, how about when you go ahead and summarizing each bullet point, starting with high availability? Can you just summarize it? Because we did talk a lot. I want everybody to understand all this, so since it's very important to the cloud benefits.
Let's start with high availability. In cloud computing, high availability means that your applications and services are designed to be always accessible and running, even if there are hardware failures or other disruptions. This is often achieved through redundancy and failover mechanisms.
How about scalability next?
Scalability refers to the ability of a cloud system to handle a growing amount of work or to scale down during periods of low demand. This can be done by automatically adding or removing resources as needed, ensuring that performance is maintained without overspending. Elasticity is similar to scalability, but it focuses on the ability to quickly and automatically adapt to changes in demand. This means that cloud resources can be scaled up or down in real time based on the current needs of your applications and services.
How about predictability?
Predictability refers to the ability to accurately forecast the costs, performance, and resource needs of cloud services. This helps organizations plan their budgets and optimize their cloud usage, avoiding unexpected costs.
About security?
Okay, in the cloud, security is typically enhanced through various measures, including robust access controls, data encryption, network segmentation, threat detection, and regular security audits. These measures are often implemented by the cloud provider, helping protect customer data from unauthorized access, loss, and other threats.
How about governance?
Cloud governance refers to the policies and processes used to manage and control cloud resources. This helps organizations ensure that cloud usage aligns with their business objectives and security requirements, and that cloud resources are utilized efficiently and effectively.
About manageability?
Cloud manageability refers to the ease with which cloud resources can be controlled, monitored, and maintained. Cloud platforms provide tools and services that make it simpler to deploy, configure, and manage both infrastructure and applications.
All right, let's move on to the next slide. So let's describe the cloud service types in Module 3.
The current slide says, Module 3, describe cloud service types. Is there anything else I can help with?
All right, go ahead, present it.
Current slide is titled Module 3, Introduction. It states that after completing this module, you will be able to 1. Describe infrastructure as a service, IaaS. 2. Describe platform as a service, PaaS. 3. Describe software as a service, SaaS. And 4. Identify appropriate use cases for each cloud service, IaaS, PaaS, SaaS. Is there anything else I can do?
Go ahead, explain infrastructure as a service and make it easier to understand.
The current slide is titled Infrastructure as a Service, IaaS. The slide explains that IaaS means building pay-as-you-go IT infrastructure by renting servers, virtual machines, storage, networks, and operating systems from a cloud provider. The slide also shows a diagram with the label IaaS connected to 3 components: servers and storage, networking firewalls/security, and a data center or physical plant/building. Is there anything else I can help you with?
Elaborate more about infrastructure as a service and how virtual machine, storage, and networking is important to infrastructure.
So infrastructure as a service, or IaaS, provides the core building blocks of IT, including virtual machines, storage, and networking. With IaaS, businesses can rent these resources on demand, scaling up or down as needed, without having to manage physical hardware. This allows companies to focus on application development and innovation rather than spending time and money on maintaining physical servers. Is there anything else I can help you with?
Let's move on with the next slide. That's very good.
The next slide is titled Platform as a Service, PaaS. It explains PaaS as providing an environment for developing, testing, delivering, and managing software applications. It shows a diagram where PaaS is connected to the development environment, the test environment, and the delivery environment. Is there anything else I can help you with?
Give it more realistic explanation in the real world. How would these people understand? How would people understand what PaaS is for them? And who in the IT world needs to be a PaaS? Who's going to use PaaS in the IT world?
So PaaS, or Platform as a Service, is like a set of tools and services that helps developers create and manage software applications. It is typically used by software developers who want to focus on coding and innovation instead of spending time on infrastructure management. This is useful for both developing new applications and updating existing ones. PaaS provides the environment and tools to do this without having to maintain underlying hardware and systems. Is there anything else I can help with?
So, in sense of a developer, what do they have to do to get started with a PaaS? What do they have to do in Azure to get started with PaaS?
To start using PaaS, a developer would need to choose a PaaS provider like Microsoft Azure. After that, they would need to set up an account and then select their desired environment for application development. PaaS usually has the tools and frameworks for developers to start coding their application. Is there anything else I can assist you with?
No, that's great. Let's move on to Software as a Service, SaaS.
The next slide is titled Software as a Service, SaaS. It explains SaaS as a way for users to connect to and use cloud-based apps over the internet, giving the examples of Microsoft Office 365, email, and calendars. The diagram shows SAT on top of PaaS and IaaS and connected to hosted applications/apps. Is there anything else I can help you with?
So, in the sense of a software as a service, can you give another example of a software that's SaaS based, that's not hosted by Microsoft, like Salesforce and more?
A SaaS-based service that is not hosted by Microsoft would be Salesforce, which provides customer relationship management and other business tools. There are many other SaaS options, such as Google Workspace for productivity or Adobe Creative Cloud for creative tools. Is there anything else I can help you with?
So, in the SaaS base, it's a subscription model. Can you explain the difference between subscription model and perpetual licensing?
In a subscription model, you pay a recurring fee to access and use the software, often monthly or annually, and you usually get updates included. In a perpetual license model, you pay a one-time fee to use the software indefinitely, but you will likely have to pay extra for major updates or new versions. Is there anything else I can help you with?
Your first task is shared responsibility model. Explain that.
Let's discuss the shared responsibility model. This model is important for understanding how responsibilities are divided between the cloud provider, like Microsoft in this case, and the customer. As you can see in the diagram, there are several areas of responsibility, categorized by the type of service that's being used. There are three main service categories: SaaS, PaaS, and IaaS, as well as the on-premise model. The responsibilities that are always retained by the customer are shown at the top of the diagram and include information, data, devices, accounts, and identities. Then, in the middle, we see the responsibilities vary by the type of service. The last category are responsibilities that are transferred to the cloud provider, things such as physical hosts, networks, and the physical data center.
That's great, but in the sense of the SaaS, I see that the customer is responsible for account and data, information and data, device and mobile PCs, and account identities. Explain that a little bit more.
Yes. Sure, let's dive a little deeper into the shared responsibility model, focusing on the customer's responsibilities within the SaaS environment. As we saw, the top section of this diagram represents areas where the customer is always responsible. Specifically, in a SaaS environment, the customer is responsible for the information and data they input into the application and for managing the devices that access it. They're also responsible for managing the accounts and identities of the users who are granted access. It is important to understand that while the cloud provider handles the application itself, it's up to the customer to ensure the security and compliance of their own data and the devices and user accounts they manage. The same applies to all cloud service types. The customer has the ultimate responsibility to manage access to their accounts and their data. Does that help to clarify the shared responsibility model for you?
That is perfect, but so you're saying that customer should not give their account access to anybody or click on phishing email or just opt out of MFA?
Yes, that's absolutely correct. In the shared responsibility model, you should not give your account access to just anybody, and you should be cautious not to click on any suspicious links or phishing emails, and you should enable MFA where applicable. These practices help ensure that the customer, ultimately, maintains security control of their environment.
That's wonderful. Now explain that in the sense of PaaS.
Let's talk about the shared responsibility model within the context of Platform as a Service, or PaaS. In this model, the customer has more responsibility compared to SaaS, and the provider takes on more than in an IaaS model. In the PaaS model, the customer is responsible for their own data, applications, accounts, and identities, and some aspects of the operating system and network controls. However, the provider takes on more responsibility than in IaaS by managing more of the underlying infrastructure, like the physical hosts, the physical network, and the physical data center. For example, in the PaaS model, a customer might be responsible for developing the application itself, while the cloud provider takes care of all the infrastructure that supports it, such as the hardware and the platform. Does that help you to understand how the shared responsibility model applies to PaaS?
Yes, that makes sense. Now, infrastructure is going to be interesting. Can you explain that in the sense of IaaS? Because it looks like we have more customer responsibility. So make them aware of their responsibility so they know what they're getting into.
Right. In an infrastructure as a service or IaaS model, the customer has more responsibility, especially regarding the infrastructure. In the shared responsibility model, with IaaS, customer manages not only their data, devices, accounts, and identities, but also the operating system and network controls, along with the applications. In this scenario, the cloud provider only takes responsibility for the very base level, which includes the physical hosts, the physical network, and the physical data center. So in IaaS, the customer manages their own virtual servers and has to install the operating system and configure network controls and manage patches for any software running in the virtual server. It is important to note that this does not include the physical infrastructure of those servers which the provider maintains. Does that clarification help?
Yes, so that means, in other words, they will need a person full time to be able to maintain their SaaS base or infrastructure service base.
Yes, you're right. With IaaS, the customer needs to have an IT person, or potentially even a team, working full-time to manage the operating system, the network, the applications, and maintain the infrastructure that the customer is responsible for.
That's interesting. Give me some of the job title this infrastructure service team would have and what kind of pay they're going to be looking into having.
Some job titles you might see for an infrastructure service team include System Administrator, Network Engineer, Cloud Architect, DevOps Engineer, and Security Analyst. The pay for those roles can vary widely, depending on experience, location, and company, but these are generally high-demand roles that pay well. For a System Administrator, the average salary might range from $70,000 to $110,000. Network engineers could expect between $80,000 to $130,000. For Cloud Architects, the average range may be between $120,000 and $180,000. DevOps engineers could range from $110,000 to $160,000, and security analysts tend to range between $90,000 to $150,000. I want to emphasize that these numbers can change considerably depending on the specific employer and their location. Does this give you a general idea of the job titles and pay?
Yes, that's very good. Let's talk about now on-prem, which is everything is a customer responsibility. This is frightening. So give me more information about this, and we're going to talk about the job type, job title for this as well.
Absolutely. When it comes to on-premise infrastructure, the customer is responsible for everything, and that includes information and data, devices, accounts and identities, applications, network controls, operating systems, physical hosts, physical networks, and the physical data center. In essence, the customer operates like their own service provider. This means that they need a robust IT team to handle all aspects of the operation, including hardware, software, patching, and ensuring security across the board. Therefore, you would need to have a range of IT professionals working at the organization, and this could include those mentioned previously, such as network engineers, system administrators, cloud architects, security specialists, and database administrators. This is a large undertaking for any organization, so it's no wonder you might find it frightening. Does
Yes,
this clarify the
so in this case, give me some of the companies that would actually take on having everything on-prem. Example companies or organization or employer types.
Sure, there are still a number of organizations that choose to manage their entire infrastructure on-premise. Typically, these are large enterprises that have very specific security and regulatory requirements. Examples might include some government agencies, large financial institutions, healthcare providers, and some companies in the defense industry. These types of organizations often have extensive resources to dedicate to managing the entire infrastructure and might choose to do so for maximum control and security. They often already have significant infrastructure in place before the advent of cloud services, and therefore don't feel the need to migrate to cloud service providers. Does that give you some insight into the types of organizations that use on-premise solutions?
Yeah, that's pretty good. So let's move on next. Now we have
Okay,
cloud service
so
comparison.
let's talk about the cloud service comparison. As you can see in this slide, we're looking at the three main cloud service models: IaaS, PaaS, and SaaS. IaaS, which stands for Infrastructure as a Service, is the most flexible option. With this service, the customer configures and manages all of their hardware. Next, we have PaaS, or Platform as a Service, which focuses on application development, with platform management handled by the provider. Lastly, there is SaaS, or Software as a Service, which follows a pay-as-you-go pricing model, where the customer pays for software they access on a subscription basis. Each model offers different advantages and is suitable for different business requirements. Are there any of these that you would like to explore further?
Oh no, at this point we're good. So let's continue on to I think we're done. We're done. So, all right, guys, thanks for watching. That was our learning path for the MS-900 certification. I hope that you enjoyed it. We definitely appreciate Google AI for presenting this for us. It was very helpful. Obviously, you can see we have a lot to cover, so it was good to have the AI kind of explain it. And hopefully, you guys enjoy this type of model or concept that we're trying to come up with. Because again, in this channel, we're always innovating, and so we try to give you guys something that most people won't do. So we know it's a little bit longer video, but there's more to come. If you like this type of video, please hit the like button and subscribe. And thank you for being a member. If you're a member, if you're not a member, consider being a member. That will help fund the channel so much. Thank you. Bye.